Oh, well, it seems to work. Yeah, recording is running. That's great. All right. Welcome to my little webinar about how to use AI and event modeling to analyze and also modernize legacy systems. Why am I talking about this? This is something I've been experimenting with in the last few weeks quite extensively. Dealing with legacy code bases is always something that is truly annoying. At least it annoys me because you always have to think about where do I even start, because it's just hard to navigate legacy code bases. And then I thought, why not use AI for this? Everybody's using AI to generate code. AI is much better to analyze existing code because they've been trained on all these legacy code bases. So why not try to use it? And it turns out this works amazingly well. And I just want to show you today how I do it, how it works. And you will get the prompt, the repositories, everything. You can try this out yourself right after this webinar if you want. So let me just share my screen. I will give you a brief introduction to event modeling and what this is all about. And then we will jump directly into some legacy code analysis. So the informational part is very short, hopefully. We will stick most of the time in real code bases. I have two code bases that we can analyze today, we can play around with today. And I just want to show you how that works. Well, understanding and modernizing legacy code systems is what we're talking about today, and especially with event modeling and AI. So who am I? Quick introduction to myself, very, very short. I'm Martin. I'm from Germany. Most probably you've heard about me because I talk about event modeling all day. If you're on LinkedIn, most probably you've seen one or two of my articles. I write almost daily about event modeling, and I'm basically the guide for your organization. If you want to adopt event sourcing, if you want to adopt event modeling, I basically help companies get into the right mindset and adopt all these wonderful methodologies because they simply work. What I provide is sensible tooling. I have the Miro event modeling toolkit. You will see this today. That's just a Miro extension that allows you to use a little bit of event modeling within Miro. I give workshops and trainings for companies, and I give sensible consulting. So I just help companies adopt all these things. What I notice is most problems we face, even independent of if it's a legacy code base or if it's a brand new code base, it's never about technology. Especially in legacy code bases, you think it's technology that holds you back. It's not. The real problem is we don't know what these systems are doing. The real problem is if you would have clear requirements, very clear requirements, any code base can be rebuilt in a short amount of time. The problem is we almost never know what these systems are even doing. So the real question is, what does the system even do? And if you have to navigate one of these legacy code bases, it's really hard to understand what the system does. And the longer you work with this legacy code base, the more this question comes up. Why the heck does this even work? This should not work at all. Happens all the time. Nobody knows why the system works. It does, and that's good, so better don't touch it. Well, that's not the best way to work with it. It all comes back to bad communication, misunderstandings, wrong assumptions. We simply don't have the right requirements. Bad and misunderstood requirements. It doesn't matter if it's a legacy code base or if it's a greenfield project, it's always the same problem. Well, how do you modernize a system if you don't know what it does? How do you modernize something that is a black box? This is really hard. It's a hard problem because the requirement we typically get is something like modernize as is. You want to take the existing system and just put it on a modern technology stack, so you're able to work with it. But if you don't know what this does, it's really hard to modernize something. How do you tackle that? Read the code? Well, typically, if you have a code base that has 2 million lines of code, 5 million lines of code, or 10 million lines of code, good luck with that. It will require weeks, months, or years. So this is typically not sustainable. Reading the tests? Typically, there are no tests, and if there are tests, they're typically disabled. So depending a little bit on the code base, but tests, of course, if there are tests, that's a good indication of what the system does, but oftentimes these tests are pretty worthless. Documentation typically last updated in 2013, and all the stakeholders retired 2 years ago. So that's typical real legacy system you have to deal with, and now you should modernize it and bring it to a modern stack. Great, wonderful. One thing I wanted to notice, everything you see today is also part of the modeling workshop on the 28th and 29th. There's exactly one seat left. So if you want to join this workshop, this is the URL. I would love to have you in this workshop. We will talk about event modeling. It's a starting workshop. You will learn about event modeling. You will learn how to apply everything. And we will also talk a little bit about this whole AI integration. So if you want to join, this is the URL. Feel free to join there. Okay, the real question that I was thinking about in the last few weeks, how do we speed up this whole process? I do not want to read legacy code bases. I do not want to read all this code that I don't understand. How can we speed this up? Well, of course, we are using AI for this, and we are using event modeling. And the combination is just wonderful. The combination is exactly what you need to analyze existing legacy code bases. The one term I coined for this is not event modeling, but if we are going into legacy code bases, what we're doing is event modeling. Not sure if you've ever been in this situation, but many code bases I have to work with, they feel a little bit like this big ball of mud you see here, and you don't know where to even start. So if you use event modeling to navigate existing code bases, sometimes it feels like event modeling. There is a book I wrote about how to apply event sourcing, especially for the whole software delivery life cycle. It's called Understanding Event Sourcing. It's not only about event sourcing, it's also about the whole process behind it, how to apply event modeling to find the real requirements, how to work with your stakeholders. That might be interesting. Let me give you a brief introduction to what event modeling or event modeling actually is, because it's really simple. I can explain event modeling in about 5 minutes and everybody will understand it, because we only have 5 key elements we use to describe systems. The first is an event. An event is just something that actually happened in our system. This is the only thing you need to describe all the facts in our system. What happened in our system? Could be a customer was registered, could be something, an email was sent. Anything that happened in our system can be described as an event. This doesn't mean that event modeling only works for event-driven systems or even event-sourced systems. Not at all. This also works perfectly well for legacy systems, and this is something we will see today. So event is just something that happened in the system, no matter if it's event-sourced, if it's event-driven, if it's your relational database, or something completely different. The next element we use is a command. So a command is just something you want to happen in the system. It hasn't happened yet. It's just something you want to happen in the system. It's an instruction to your system to do something. Could be something like, please register this customer for me. An API call, for example, could be a Kafka record that comes in, something that instructs our system to do something. Technology doesn't matter in event modeling. It's really completely irrelevant what the technology behind it is. We talk about information flow. We talk about information. And how the implementation looks like is completely irrelevant. So now we have events, something that happened in the system. We have commands, something we want to happen in the system. The next one is a read model. Read model is just how do we make sense of the information that is already available in the system. We have all the events, could be information in our relational database. How do we use this information? This is what read models are for. We simply connect, and you will see this in a second. We connect all the events in our event model to read models, and we could basically project information for screens or project information for background processes, something that uses the information in the system. The next thing we use in event modeling is screens. We use a lot of screens. We use a lot of UX just to describe how the system actually works. This is really important, something people love to skip, but screens are really important, so people really understand what are we discussing. So screens is often even something I start with. When we model a system, when we describe a system, I often start with screens, because screens is something everybody understands and is very easy to grasp what the system does. And the last thing we need is side effects of what happened in the system. It's basically our background processes. Not everything happens by a click on a button or something. We also have background processes. We call them processes or automations. And that is all we need to describe a system with event modeling. These are the 5 elements, and you can describe any system in the world using only these 5 elements. You don't need more than this. Oftentimes, people who are new to event modeling love to come up with new things, new elements. Believe me, you don't need it. This, what you see here, is everything you need to describe any system in the world, no matter how complicated it seems. We combine these 5 elements into 4 patterns. First one is a state change slice. We call this state change. State change because we change the state of our system. So typically it looks like this. You have a screen. The screen has, for example, a button. The button, a click on this button triggers a command. And if the command is executed successfully, it results in an event in the system, a new event. A new event in the system always means our system has changed or evolved in some way or the other. The next thing is a state view slice. So we use all the events we already have in the system, and we just connect it to a read model, and the read model provides information to a screen. So we simply describe how do we use the information in our system. The next thing is an automation. It's just a combination of a state view and a state change. So basically describing a typical background process in our system. How does this background process get information? This is what the read model is for. And what is the next action this background process is triggering? That's the command. And this simply describes one step in our system, one background process. And the last thing we need is a translation, because oftentimes we need information from external systems, from other systems, which is not our system, especially when we talk about legacy integrations. That's oftentimes an important pattern. How do we get information into our system? And this is what translation patterns are for. And that's all you need. These 4 patterns and 5 elements is all you need to describe systems completely. And the neat thing is, if you describe systems with event modeling, you end up with something like this. We call them slices. Slices are basically the small building blocks that make up our processes. You see here, slices are very simple. It could be a UI that triggers a command and results in an event. That's one slice. And the great thing is, typically these slices are really self-contained. So this is a business capability, an action in the system that can be described completely in isolation from the next step. All these slices can be independent from each other, and we basically break our system down into tiny building blocks, which is really, really helpful to reason about the system, and which is really helpful for AI. We will see this in a second, because slices allow the AI to work with very small context sizes. AI does never have to look at our whole system. We only reason about simple and single slices, which is very, very small and very clearly defined. And this really helps AI to make the right decisions. And we will see this in a second, hopefully. The one thing that is missing for slices, we need to describe the behavior. So it's not only about what happens in the system, but also what are the business rules behind it. So if we have something like this, the user clicks on a button, oftentimes there are business rules behind that. And in event modeling, we use given, when, thens for that. So what is a given, when, then? Let's assume we have a simple slice like this. It's a cinema ticketing slice. You can reserve a ticket, and if the reservation is successful, you have a ticket reserved. But of course, an operation like that has tons and tons of business rules typically. And we can describe these business rules with given, when, thens. Given always means we set our system into a certain slice. When means with this system in this state in given, when we execute a command, what do we expect to happen? And this is what then describes. So given our system is in a certain state, when we execute the reserve ticket command, for example, then we expect our system to be in a new state, which means there is a new event available. Here's a very simple example. Given nothing, our system is completely empty. We just started the servers. When someone tries to reserve a ticket, it should work, and this person should be able to reserve a ticket. Very simple use case. But oftentimes there are many more business rules. So for example, given we have an event like capacity limit reached, whether this is a good event or not, that's debatable, but let's assume we have this event. So the capacity is, we are out of capacity. There are no more reservations possible. But when someone tries to do another reservation, it should result in an error. Great, that describes the business rule for our system. Or let's look at this. Given the seat with the ID 5 is already reserved. If we want to reserve the same seat again, same error. We cannot receive a seat twice. And using this, you can describe each slice and all the business rules behind it completely. This allows you to really step-by-step describe the system with given, when, thens. And this is really, really helpful, because you describe these given, when, thens together with your business experts, ideally, or with the AI. And This allows you to describe the information flow in the event model plus the business rules for each slice. And this is enough to implement the system, to use the event model as a blueprint for implementation, which is really, really interesting. And you will see examples of this in a second. Now, if you have 2 million lines of code, where do you even start? How do you do that? Well, modeling requires understanding. So you need to understand the code base. What if we use AI to really analyze our code base and build the event models for us? What if we model the system together with AI? And what if it would be possible to generate the new system directly from the event model? This would allow us to very quickly go from a legacy code base to an event model, understand what the system actually does, and then use this event model to generate code for the new system. And this is exactly what we will try to do today. Let's try this. So, of course, if you have any questions during the webinar, feel free to just jump in and ask. It's not a monologue that I want to do today. You can ask any questions you want. Are there any questions? Something you're interested in right now? So there is a Miro board I will share in a second. You can join this Miro board if I find the chat button here. On this Miro board, you find the links to the repositories I will be using. So you can join this Miro board. You will find everything there, and you can try this out yourself. I will just now start with one code base. And the code base we will start with is a very simple code base, and many of you might know it. That's the Spring Pet Clinic. The Spring Pet Clinic is one of the CRUD applications that almost every Java developer knows, and I think there are even Spring Pet Clinic implementations for .NET. It's a typical CRUD application using Spring Data JPA, and all the technologies that you would expect in a legacy application. This application is still maintained today, so it's not that this application is no longer maintained or something. It's still maintained today. It's a blueprint how you would build CRUD applications with Spring, but it's a perfect example how you could use AI to analyze an existing code base. And what I will do now is basically just use this code base as is. I will not look at the code at all and just ask AI to analyze this and give me the high-level flows in the system. And we could then build event models from these high-level flows. Let's see how that works. Now I will jump directly to the terminal here. And what you see here is this is the Spring Pet Clinic, the Kotlin variant. So it's the Kotlin version. There are different versions for the Spring Pet Clinic, a Java version, a Kotlin version, and you will find versions for almost any language. And what I have here is, in this repository, is a Claude MD file. The Claude MD file is just the instructions for Claude. So I'm using Claude Code, how to analyze the code base, what to look for, and how to build the event model, the slices, and the elements from the existing code base. So basically what the AI will look at is all the endpoints in our system, all the APIs, how to analyze this and how to process it. So we are looking for REST endpoints, we are looking for Kafka brokers, anything that brings data into the system and anything that brings data out of the system. And the AI will analyze all these endpoints and try to figure out how does the system actually work. There was a question.
Yeah, Martin, my question is this just a prompt or is a definition of an agent that you will load into Claude?
No, that is the Claude rules file that you can use. So I'm just using Claude Code, but you can of course use an agent as well. But this is just the rules file for Claude. So I will just start Claude now, and I will tell it to analyze the existing code base. Let's see if that works. So that's all we need, and I will just say read the instructions. Just instructing Claude to read the instructions, and it will immediately ask me, well, what do you want to start with? There are two ways you can start. The first thing I do typically is I will look for a high-level analysis, which gives me just the high-level event model to guide me through what flows are available in the system, how does this actually work. So let's say we create the high-level analysis. Let's see if that works. And this works pretty well. This is a very small code base, but in the next step, we will look at the code base with about 2 million lines of code, and in that it works equally well. Let's see how fast that goes. Now you see here what it does is it goes to the code base, it looks for REST controllers, it looks for how does information get into the system. It knows exactly what to look for and what could define a slice. It will also analyze unit tests to find the business rules, and from the unit tests, it will try to derive some given when-thens. Let's see. Let's make this a little bit smaller. All right. So exploring the code base, still doing its thing. Now we see mapping operations to slices. Great, create the high-level event model structure. And that's a great starting point. The high-level structure is a great starting point because you have a high-level overview, what happens in the system, what are the flows, and you can use this high-level structure then to dive deeper into certain flows in the system. You will see this in a second. What you get typically is, you see it here in the last step, it always creates JSON definitions. These JSON definitions can then be imported into the Miro toolkit because it understands the structure that Claude is creating here. So let's give it a second.
Martin, can I ask you, how much time have you spent on instructing Claude here in the Claude Markdown? Is that a hard thing to do, or is it fairly simple?
There was quite a bit of experimentation necessary to get it to a state where it really simply works. But the Claude file you'll find in the Spring Pet Clinic repository and also in the other repository is pretty mature. So you can analyze any code base with it, and it should give you fairly decent results. Of course, depending on the code base, some tweaking might be necessary, but it's a great starting point. So you shouldn't have to do much to get good results. It just works. If it's doing yeah, here we go. There's the high-level analysis. Do we want me to write that? That would be great. Wolf, yes.
On which kind of code bases did you test the file? Only on the pet clinic, or have you
made
experiences with others?
I tried a few bigger code bases which are freely available, but also 4 code bases with customers. So it's not only I really tried this with customers, and I also gave this to colleagues, and they tried it with their projects, and most gave me the feedback it just works. It's a really great starting point.
Okay, not regarding the language, the programming language.
Most of them was Java, but there was also .NET, and I think one Python code base I'm also aware of. So it doesn't really make any difference, because that's exactly what the AI models are trained on. They are trained on all these legacy code bases. They know exactly how they are structured. That's basically a match made in heaven. Okay, so it just told me it has created the high-level analysis. Do we have it here? Yes, here it is. High-level analysis JSON. Now what I'm doing now is I just copy this JSON file and I jump to Miro. That's all you need to do. Jump to Miro, and I'm looking for an empty space here. What you see on the left is the Miro event modeling toolkit. This is freely available, so you can just install it, and there is also a web version of it. So I will show you the web version in a second. But what you can do here is just go to the last tab here, say import model, and you can simply paste the JSON here. And if I do that, it will now import the event model. Let's see what it comes up with. So you see there are no fields defined. This is the high-level model. It tells you what is the flow in the system. That's all we are interested in here. Get a first impression. How big is the system? What is going on in the system? What are the flows? That's all we need. So we see, what do we have here? There's something like owner registration. We have something like owner update mechanisms, pet management. We can add pets, update pets. Great, sounds good. Schedule visits. So there's something like visit management. That's also great. And we have veterinarians. These are the flows here. And now what you can do is you can use this high-level thing. So typically what I do is I define, we call them chapters here. So we have a few chapters here. And this is also what you get from the analysis. So if we go back to the plot file here, and we say again, read the instructions, it will tell us which flows are available. And the flows are basically the same here. So this is something like owner management. We use these blue arrows for this. So here we have owner management, for example. And now, since we understand this high-level flow in our system, we can decide to dive deeper into one of these flows here. For example, how does the owner management actually work? What is possible with the owner management? And if you look at that, create a detailed flow analysis. So again, it asks us, should we do the high-level analysis again, or do you want a detailed flow analysis? Now we're going into a detailed flow analysis. It should ask me now, which flow do you want to analyze? Because I identified a handful of flows. Let's see what it comes up with. Exactly. Owner management, pet management, visit management, veterinarian management. These are the flows that Claude identified. And now we can say, which one do we want to dive deeper into? Your choice. Which one should we do? We have owner management, pet management, visit management, or veterinarian management. Which one should we analyze? Any preference?
Pet.
Pet? Of course, it's always pets. All right, let's analyze the pets. Pet management. So let's analyze the full pet management flow. I give it the instruction, make sure to model the whole flow. Claude tends to skip slices if you don't instruct it well. Now it will just start to analyze, going deeper into this pet management flow. So you're starting with the high-level flow. This allows you to identify the simple flows in the system. Now you know how the system is structured. Then you can go into each flow in detail. So for example, if we want to modernize the pet domain, we could say we want to create a new microservice that takes care of the pets. And the event model would allow us to just dive deeper into the pet management and uncover what does this actually mean. And the great thing is, if you go into the detailed flows, it will also try to build the given when then. So also the business rules will be part of the event model. Let's see what it comes up with. Good, already a few tasks resolved. I did work quite a bit with AI today, so I might run out of tokens. Let's see. Now it checks the unit test for specifications, tries to derive some given when thens. That's good. And in the end, it will hopefully create a nice JSON for us. Any questions in the meantime, while we are waiting for AI? Just ask. Don't wait because I cannot see you. Just ask.
How does it? Oh, sorry.
Okay, Danny, go first.
Oh, okay, thank. Do you know if the AI can make meaningful storylines, or is it just random which kind of flow it comes in?
Yeah, very good question. So oftentimes it works quite well, but you always have to do some manual adjustments because exactly the order of slices oftentimes is not easily derived from just APIs and stuff like that. So you will have to do some manual adjustments. And oftentimes, so what I think is the best flow is do the high-level analysis, generate a detailed model analysis, for example, for the pet flow, and then is the time to sit down with your business experts or whoever knows something about pets and sketch out the very details of the event model. There you go really into the details and define, okay, how does this really work or how should it work? And then you use the event model as a base for your new system, for example, you want to build. This is how I think is the flow that works best. Rolf?
Maybe you can have a look at the questions in the chat. Meanwhile, there are some.
I don't see the chat because I'm sharing, but let me jump over.
There was one question about the read model in front of every process. I think you mentioned it once in one of your videos that it makes sense to do it, although it's not implemented every time. Maybe you can elaborate on this.
Yes. Let me just quickly tell Claude to write the JSON. Just do it. Yeah, if you look at this, the read models here that you have here is not necessarily something you have in code. The read model here is just, it tells you in some way or the other, we are reading information. This could also be just an event listener or something, and there is no real implementation for the read model. This question comes up all the time. What the event model is not the implementation. That's a really, really important distinction. Event model is not the implementation. What you see here is the information flow. If you build an event source system, it will look very similar to what you see here, but not all elements in the event model do have a representation in code. Very, very important distinction. Okay, let's jump to the chat. If there are, that's the problem with sharing. Here is the chat. How you prevent to get every time you ask for detailed flow a different model? Typically, what I do is you can instruct it to just go to the detailed flow if there is already this high-level analysis JSON. You can do that, but I just start Claude and say what I want to do. So I want to now do the detailed analysis for one of the flows, and that's nothing I'm really bothered with. When do examples come into play? With examples, you mean given when dense, or what does that mean? Ivan? Sample data, yeah. You use this in a given when then, and we will see this in a second when we import the model, hopefully, because Claude also looks at the example data from tests and stuff and tries to put that into our given when thens. You can still implement a CRUD application with event modeling. Absolutely, of course you can. So event modeling doesn't tell anything about the implementation. Oftentimes, it's a perfect playground to plan your CRUD system. I mean, obviously, I'm biased. I'm a very big fanboy of event sourcing. I wouldn't build a CRUD system if I'm not forced to, but event modeling itself doesn't care about implementation. I will share the repository. If you joined this webinar, if you were invited here, I will share everything. You will get a message from me on LinkedIn. I will share everything, links. You will get everything after the webinar. Don't worry. So I do find the need to add a read model in front of every process a bit unnecessary. Yeah, that depends. Claude Pro is not enough sometimes. Yeah. All right. So let's see if I have a new example. Yeah, it created something. It's in config pet management detail JSON. Let's see what it came up with. Baby copy. The trick is, because you mentioned Claude Max, if you work with AI in a sensible way, you don't need Claude Max. You don't need it. Because if you work with slices, your context size is very, very small. And this allows you to work with your code base without burning millions and millions of tokens. So it's really, Claude Max is nice, of course, but you don't really need it. You can get very far without it. Okay, let me import this. Let's see what it came up with. Again, import model, putting in the JSON. And now you see it also imports given when thens. Oh, I should have made a little bit more room. This slice here has a lot of given when thens. We can already zoom in. So here, for example, let's look at this. reject a pet with a missing name. So it really looks at the test cases and tries to come up with the given when dance. So now I'm really messing the things up, but this doesn't really matter. Let's wait a second. So this is how pet management works. So we have the owner with pets, which is a read model. Then we can add a pet, which results in a pet added. We have available pet types. And then there is this update pet operation. I mean, this is a simple application, right? But looking at this, it understands your code base, and this works also for complex code bases. So what you do always is you start with a high-level analysis, and then you dive deeper and deeper and deeper into these flows. And I will show you in a second how this looks like in a bigger code base. Rolf, another question?
I think that also answers. I think that also answers the question for examples. You can have both examples here in the model itself. These are examples, not testable examples, just to show how the data looks like. And you can have examples in your given when then tests.
Yes,
then
exactly.
This is something that you will really test.
Exactly. So you see, it puts in examples here, and these examples are either from test cases directly, or it makes them up, but in a meaningful way. So it really tries to, and this is, if you look at the prompt file, the rules file, this is something that is explicitly stated in the rules file. You need to make up meaningful examples, if possible. So if you look at a bigger code base, I have an example for a bigger code base here. The code base I used here is Metasfresh. This is an open source enterprise ERM system. And if we look at Metasfresh, it's here. Metasfresh. Let me make this a little bit bigger. This is a pretty big application. It's maintained since 2015, and it has more than 2 million lines of code. So if you look at how many lines of code are in there in the backend, let's just quickly see what we are dealing with here. So it's about 10 years, tons and tons of commits, and tons and tons of functionalities. An enterprise ERP system, open source. But you can also analyze this. And I will show you in a second how the analysis looked like for this system. And it took about, to build what I'm showing you in a second, took about 25 minutes. So it's really not a lot of time you need to get a first impression and the first understanding of your existing code base, even if it's 2 million lines of code. Okay, you see that's a lot of things going on here. I'm just, I want to show you how big this code base is for the analysis. So here it is. So you see this is mainly a Java application. Yeah, 20,000 files. Java and SQL definitely makes up the majority of the code base. And in the end, what we have is about 2 million lines of code and 1.3 million lines of SQL code. And that is what we analyze with Cloud Code. So the result of this analysis was this here. So this is the high-level analysis. This is the high-level flow. And if you look at that, that's really interesting. It tells you basically what are we dealing with here. So we have sales orders. That's one thing we're dealing with. Then there are shipments, items that get picked. So this is again shipments, but if shipments are created, there's a connection to invoices. So shipments and invoices are somehow linked and connected. It's the whole invoice management, post accounts, purchase orders, goods, and inventory management, and so on and so forth, issues, and so on and so forth. So you see, you can analyze and see, okay, what are the high-level flows we are dealing with here on a very high level. And then what you can do is you just pick one. For example, shipments. You go again to Claude and say, okay, let's dive deeper into shipments. I want to understand how shipments work. This results in something like this. That's the next detailed analysis. How do shipments work? So you see, okay, shipment have schedules. So we create a shipment schedule. Also with the attributes here, you see already what are the attributes we are dealing with here. And if you look at the code, these attributes is the same that you find in the code base. Then we have something like picking job, pick items, and generate shipments from pick items. So basically that shows you how this flow works. And then you can dive even deeper. Picking jobs. How do picking jobs work? The very same thing. Go again to Claude and just instruct it, okay, give me the details for the picking job. And here you go really into the details already. So this is really showing you step by step how the picking jobs work. And I didn't make any adjustments to this. So this is exactly what Claude gave me. I did the analysis today. So this is nothing I made up. This is really directly the output of Claude imported in Miro. And if you look at that, you can really see how picking jobs work. Picking job basically takes a shipment and prepares the transportation of it. So here we set the pick. And then the slot is picked, item for processing, and so on and so forth. So this is really, it allows you to quickly understand what is going on in this code base. And you can drill deeper and deeper and deeper until you really understand it. And this is the level of granularity I would now use and sit down with the business experts. Okay, who has knowledge about pick jobs? Sit down with them and get into the discussion. This is where event modeling really starts, but you can get a very, very fast understanding of your code base just using AI and event modeling. Yeah, questions? Wolf, I'm just seeing you, so yeah.
I also wrote this to the chat. How do you know where you need to dive deeper and where you have already enough information in the model? Because I could not do that. Is it just possible by talking and showing it to the user experts? Or is there some information I missed here that shows me, hey, there is a lot more below?
Basically, that is something you need to find out. So you dive deeper and deeper, and here you see already, okay, this is already very detailed. Is this a flow we can work with? If you sit down with a business expert and this business expert explains to you, yes, this is how pick jobs work for us. This is the flow. Maybe we need to make a few adjustments. Then you can work on that. So as you would do in an event modeling session, you need to just decide, okay, what is the flow we want to focus on? What's the most important flow, for example? It's pick jobs. Okay, let's focus on pick jobs. Then you dive deeper and deeper and deeper until you realize, okay, this is the flow. This is how it works. This is how I would do it. Christian?
Did you also analyze something different than just legacy code? For example, just documents, PDFs or something like that to create an event model?
This is something I do all the time. So
okay.
using information is something I do all the time. So using AI to extract information, build event models from that, that's something I do almost daily. And of course, what you could do is you could not only use the legacy code base to analyze this, you could also just use Confluence pages and everything available to get a big picture of the system. So you could use anything as a source for your event model. Basically, the more the better.
Okay, thank you.
Okay, Sergey.
Turning my microphone on. Hi, everyone. Question about modern system when we have multiple microservices and we want to have overview of event models from multiple Git repositories. Can we still connect multiple Git repositories to the same Miro board so that we can have high-level overview?
Yes, what I would do then is exactly what I also do in event modeling. You just have multiple models on the board. Every microservice would have a high-level model, and you simply connect these models on the board using events. That's how I do it. So I wouldn't build one model for all microservices. This doesn't make any sense. But you would build one model for each microservice, but keep them on the same board and link them together. This allows you to have this big picture.
You link them by linking events?
Yes, because typically these services, they communicate. There are integration points. So for example, let's just use this as an example. Pick job created could be an event that also triggers a communication with another system. So there is an integration point here. And this means you can link this event to the other model, because the other model also uses pick job created. It uses the same information. And this allows you to navigate between the systems. This allows you to show the integration points. And this is also a good example where I use external events. So if you want to really show this is an event that is an integration point, I typically just mark this as an external event, which turns it yellow. And then you see already in the event model, okay, this is where the integration happens. This is where we need to focus on.
Oh, why does this turn red now, the arrows?
Because you see that some information in the command is not available in the event here. This is something you need to figure out now with the business experts. Where is the information coming from? Maybe it's coming from a UI that's just putting in this information. This is something you need to figure out. Yeah, more questions?
I have one, Martin. Now that you also call this event modeling, and we're talking about legacy code bases here, with all the information that the AI have extracted, do you know if the event model have some heuristics or can expose some fracture planes for us for boundaries and designs, for trying to unravel the big ball of mud?
Well, what it gives you the flows, and the flows are a very good starting point to look for boundaries. So if you see, okay, there is pet management, this is where you look for boundaries. And in my experience, what I've seen so far, it's pretty good in finding these very rough boundaries. So that's a really, really good starting point.
Seems good.
Any other questions? So if you look at the given when thence it created, we could now really just use this event model like this. So this basically down here, this would be the event model we use to start with our business experts. And we could now use this event model again to just generate code for our new application. So let me show you this for a second. So we could just use this, for example, to generate a quick prototype. Could we use this event model? Could this also work in an event source system, for example? How could that look like? And we could just say, we want to generate a quick prototype from that. Let me just start the prototype generator here. It's a Docker container. You can start locally. And this is the context MetaFresh picking job details. And we could just say, let's see if we can create a prototype from this. So the prototype is a code generator that is running in the background that creates a real-time prototype of the system. What you see here is we can just play around with this. So this is basically an in-browser event source system. And we can just play around with this and say, okay, we have these attributes here. How does that feel like? Can we work with this? Is it possible to create an event source system just from the event model? And if that is possible, it's a very likely that you are on the right track, because then it's also possible to generate a real production system from it, because the prototype gives you a very good indication if the model is working or not. So here, for example, we could just say, let's put in some information. Picker ID must be a UUID. This must also be a UUID. Aggregation type is something like, I don't know, shipping. And obviously, there is something like allow picking any HU, not sure what this even means. I'm not an expert here. But if we submit this, oh, great. We see we have an event here. So we can, from the event model that we just extracted from the legacy code base, we can create a running prototype from it. So it's not too bad. Actually, it seems to work. And if we have a picker here, we can even display the information. So now you could just take this event model, refine it with your business experts, and generate code from it, and do the legacy transformation directly from the event model. Generate code from it and see how far you can get with that. And this, I think this is really something that is that can speed up legacy code migrations by a magnitude of 10 or more, because you don't have this huge ramp-up times. You don't have to analyze this code. You can go extremely fast, get the event models on the board, pick the business experts, put in the details, and then generate code from that. Amazing process. All right, we are almost at the end of the webinar. That was extremely extremely fast. Any questions I can answer in the remaining time? Anything you're interested in?
Yeah, Martin, I have just an observation more than a question. So the reason why I was also suggesting that sometimes Cloud Pro is not enough is because I tend to create agent that does one thing and does good. And whenever I created just an agent that is able to research a topic, and I noticed that, if I just research, for example, event modeling, and the agent goes and start this, it almost ends up all the token for a Cloud Pro, right? So that's why I was suggesting that maybe. So the future of this prompt you see, I think I will try to make this an agent and see how far I can go, because I think that is the next evolution from this. Like maybe even more than an agent, to do 2-3 things. One agent do one thing and then pass it to the other and see how this goes. Very interesting.
Yes, something I also experiment with. Just think about this for a second. Let's say this agent is triggered every time the code base changes. So you create real-time event models from your code base, and this means you have living documentation, which just tells you how the system actually works. Live. How amazing is that? No more Confluence pages, no more static documentation. You have an event model that tells you how the system works, and you just have to git commit. How amazing is that? Crazy.
Is that something you plan to introduce to make it simpler?
Yes.
Oh,
yes.
Nice. For Christmas, maybe.
This is something I'm experimenting with, and it's possible. As soon as this is possible, it will be a total game changer. Yes. Any more questions?
Sounds great, Martin. Maybe I join it a bit later. Can you show the code being generated? Is it just front end or back end? Is it Kotlin back end and HTMX front end or something? So is it something that developer can step in and refine, polish, and make it production grade?
Yes, absolutely. I do this every day. So what is generated? You have different code generators. I can show you for a second. You have different code generators you can use, and the great thing is you can also write your own code generator. So you can use anything you want here. Let's just see.
So I can use my own archetype and best practices and serve it to AI. This is what you mean?
Absolutely, exactly. So that's the whole idea. What you get from the event model is a JSON, and you can just plug this JSON into an AI, or you can use. So what I do is I use a lot of static code generators, which generate the whole skeleton, and then I use AI to fill in the business logic, for example. And here, for example, I have a few generators for Axon. I have a generator for Emmet. I have a generator for the event catalog. They just work. You can just use them, or you can use them as a basis and build your own, or you can build your own code generator from scratch. Many customers do exactly that. So it's completely up to you what you want to do with it. Yeah, and building a code generator, using AI to build a code generator takes about 4 hours. So it's really, really quick.
I also have several questions, Martin. First, in presentation of your event model, and you said that you often start with screens because screens are very important. Yeah. But your tool for kind of analyzing legacy systems doesn't produce anything for the UI for the screens. So it looks like a big gap of like when you do event modeling, it is important, but analyzing the legacy system that is omitted. So like just comment on this tool itself, and a couple more like questions. When you work with systems that are heavy on UI, so lots of things happening on the UI with almost nothing or little things saved to backend. How well does this approach work? And somewhat related questions, but different. Lots of logic, lots of sophisticated algorithms, not that many events flow in between the systems. So 3 different questions. So, sorry for.
These are very good questions. So I didn't use this on, for example, big code bases for single page applications. No idea how well that works. That's something to play around with. So I mainly worked on backend systems until now. But of course, we need to experiment with that, and we will also refine the rules file. I think, why shouldn't it work on front-end applications? It should work, but I never tried it on a bigger code base, so I'm not sure. So regarding the screens, the prompt doesn't create any specific screens. This is either what you do manually right now by just taking screenshots and putting it into the event model, just make it visual, or you sit down with the business expert and you simply draw the screens. If you want to evolve the system, maybe the old screens is not something you are even interested in. You would just want to draw the new screens. That's depends a little bit on the process, if you just want to document the status quo or if you want to evolve the system. What was the third question? I think I missed one.
Well, yeah, the third was a little bit related. So lots of different complicated logic algorithms without not event flows happening and little saving, little showing of data, lots of complicated calculations.
But I think this would still work. This would just be one more drill into the details of one specific algorithm and let the AI create the event model for exactly this algorithm. It would just be one more model. You go deeper and deeper and deeper, and I think it would also work for the algorithm.
Okay, thank you.
My pleasure. Any more questions? No?
Can you share some links after or maybe at the end of the meeting?
Yes,
links
sure.
that you have seen, maybe some Miro plugins, custom plugins, or any GitHub repositories?
Yes. So if you are in this webinar, you will get a message from me with all the links, everything to try it yourself, everything you need to get started.
Thanks.
Great. So that's about it. So what I would love you doing now, if you get the message from me with all the links, just try this yourself and find out if that works. It's a really good playground to also, if possible, try it on your code base and just see where it comes up with. A few things we noticed was whenever the AI cannot analyze your code base, it's typically an indication that something's wrong. And oftentimes are exactly the places where there are hacks and workarounds in the architecture. It's pretty interesting. So if something is not able to analyze, that's something to have a close look in your architecture, because typically there is a problem. Very, very interesting. So just play around with your systems if possible, and just build the event models from it and get used to that, because I think it's really a great way to speed up this whole legacy system modernization. All right, then thanks for joining. It was a lot of fun. This hour went by extremely fast, but I hope you learned something, hope you saw something interesting, and then see you next time, right?
Thank you.
All right, thank you.
Thank you.
Martin.
Bye.
Thank you.
Bye.
Thanks. Bye.
Bye.
Thank you, Martin.
My pleasure.